In this AlphaCam Express presentation we cover tool definition. There are 6 different tools we can define within AlphaCam: flat end, bull nose, ball end, drill, tap and user defined. Defined tool is under machine. We'll start with the flat end tool. There's quite a few of these dialog boxes that are common across the different tool types, so we'll run through those initially. The offset number, I've just made that similar to the tool number. It's not an essential part within Express, sometimes used for machines with automatic pre-select tool changes. What is important is you get the units correct, metric or imperial, and the tool rotation correct, whether it's an M3 or an M4 for clockwise or counterclockwise. We'll define a tool that's 40mm in length, 10mm in diameter. The depth of cut is not required within AlphaCam Express. The maximum depth, I put that as 30. That generally refers to the flute length. And then we'll come down and we'll look at the feeds and speeds. You can calculate the feeds and speeds based on the feed per tooth and the number of teeth. I'm going to concentrate on the fixed speed, so we'll say this is 18,000 RPM. The feed speed of 6,000, that's millimeters per minute, or put another way, 6 meters a minute, and we'll have the down feed the same. Another common dialog box is the coolant. We can have different types of coolant. I'm going to have none on this tool. You can define an engraving tool at this point if you wish. And put on an end diameter. I'm going to refer that back to being a flat, so we'll say none. Graphically you can display a tool holder. There's 2 ways we can do this. We can simply just define that here. I've got the length and the diameter. Alternatively, if you've got the tool holder graphics, you can select this. I've got my graphic there, and then it'll ask me to save that tool. So we'll look at these other tool options. The bull nose, we've been the same size. This one allows us to put a corner radius on there. All the feeds and speeds and all the other dialog boxes are the same. A ball end, if I put in a diameter of 10, it'll automatically then give me a radius of 5. The drill, a couple of things on the drill, or the cone angle, and the peck depth. So if I put a peck depth of 10 and a maximum depth of 30, it will do that in 3 hits if I selected pecking. And then at the top we have the option of putting in the pitch and a fixed spindle speed. And finally the user defined, and for this we'll go to look at the cross section of the tool. Looking at these 2 profile tools that we have on the screen there, AlphaCam needs to understand what is the important diameter and where is the reference point on that tool. So we look at the one on the right. That little line sets the diameter. That's the important diameter because that's going to create the overall outside dimension of the door. And the circle will define what is the important Z level. To produce this draw front we require 3 tools: 3mm flat, 3mm diameter 30° engrave, and the user defined profile number 1. So we'll load the file, tool definition. We'll start by defining the 3mm flat. Maybe have that as a length of 30, diameter 3, maximum depth on that we'll do 20. Spindle speed 18,000, and we'll cut it maybe 3,000 for that, and then we'll define the tool holder graphics. Select this as the tool holder graphics and we save that as 3mm flat or flat 3mm. I could repeat that to create the engraving tool, or alternatively If I select that 3mm and right click, I can edit that tool and come into this taper and say that then I want to add a taper angle of maybe 30 on there. All the feeds and speeds I'm happy with, and just say OK, and I don't need to then go and select the tool holder graphics. Say OK and save that away as my flat 3mm with 30° taper. Finally, we'll do this profile 1. Define tool, user defined, click on that cross section. It then gives me a message, the line and circle found to set reference diameter and Z level. Say OK to that. We don't need to put a maximum depth. Well, let's put maximum depth in there at 19. I'm sure positive then that I'm not going to go deep into the panel. We'll have a spindle speed of 18,000 and maybe run with this at 7 and 7. Select the tool holder graphics and we save that away as profile number 1 external. So we load the file Rose Row Front. I have a machining style here. There is a presentation on machining styles automation that then I can apply this toolpath automatically to this row front, including our operation with the user defined tool. So we simulate this, we've got the 3mm toolpath on, and then we come in and do the engraving. And finally tool number 3. And we look at this front view, we can see that that's controlled the tool depth for us. So in summary, we showed you how you can define these 6 different tool types. We looked a little bit in closer depth at the user defined, explaining how you need to create a circle and a line to define the diameter and the Z level. And then we defined the 3 tools to create that rose fronted row front. This concludes this AlphaCam Express presentation on tool definition. Thank you for your time.